The question we're going to answer today is, what two scientists helped discover evidence to explain how the planet looks today? And to answer this question, we need to explain continental drift in seafloor spreading. Now, we start this with Alfred Wegener. And in 1910, he hypothesized that at one time, all of the continents were once joined together in a single landmass. He named it Pangaea, and it has since drifted apart and is in a process now known as continental drift. Wegener gathered the following evidence to support his hypothesis. He found evidence from land features, such as mountain ranges lining up on continents when you pieced them together. He found evidence from fossils, or traces of ancient organisms, that were preserved in rock show the same animals and plants occurred on two now separated landmasses. And there was evidence from climate change, where Wegener showed scratches on rocks made from glaciers in places with much more mild climates today. For example, in Yosemite National Park was made by glaciers. Okay, but it's just an hour outside of Fresno, and we have a very mild climate here. And so, how could it possibly be that glaciers carved out that region? Wegener couldn't provide a satisfactory explanation for the push or the pull of the continents against each other, or apart from each other. Therefore, his hypothesis was rejected. Until Harry Hess, in 1960, proposed a radical idea suggesting a process of seafloor spreading. Seafloor spreading is where the seafloor spreads apart along both sides of a mid-ocean ridge as new crust is added. Ocean floors move like a conveyor belt away from the mid-ocean ridge, carrying the continents with them. Evidence of Hess's theory of seafloor spreading included evidence from molten material, which looked like pillow-shaped rocks formed if molten material erupts and hardens quickly. There was evidence from magnetic stripes, which were rocks that lie in a pattern showing a record of reversals of Earth's magnetic field, which is a pretty trippy effect. And then there was evidence from drilling samples, which revealed that the farther from a ridge a rock was taken, the older they were. Eventually, the ocean floor sinks into deep underwater canyons called deep ocean trenches, where subduction takes place, which allows part of the ocean floor to sink back into the mantle over tens of millions of years.